Welcome everybody to the 2020 MGPHO conference in a virtual format, which seems to be the trend here this year. It's a little sad that we're not able to see everybody and hang out and tell some more stories, but hopefully soon we'll get back to that. And the hope would be for next year we'll get back to a normal conference, but we'll see. As you can see, I've got my COVID look. So a little bit less refined up here in the woods of New Hampshire. And I don't feel bad about it because I'm sure all of you are sitting at home in your PJs right now watching this. So welcome everybody. And we'll begin with the responsibility and medical gas reliability presentation. This is an overview of the changes to the 2021 edition of NFPA 99. And specifically, there's some new requirements in the operation and management section of the code. And it seems like we continue to build on those operational management requirements because we obviously recognize that these systems are important on an ongoing basis. So we continue to try to increase reliability based on that. So most of you know me, but if you don't, I'm Jonathan Willard. Company that I started some time ago is Acute Medical Gas Services, which is located here in New Hampshire. Comprehensive service company. I've been in the healthcare construction world for over 20 years. Started out building hospitals, working with a large mechanical contractor. We did a ton of healthcare work. So that's kind of how I grew up, got into verifications 12 or 14 years ago or so. And kind of been doing that ever since. And I'm also a principal member of the technical committee for medical gas and vacuum systems, NFPA 99, as well as a technical committee principal member for NFPA 55, which deals more with the bulk gas systems. And we also offer a 100% online certification programs. And if you've been involved with those. We were the first on the market and continue to be the market leader, and we are doing a huge upgrade in the very near future. So keep an eye out for that, and we'll continue to do our best to educate folks. And remote education is more important than ever, I'm sure, as most of you know. So just a little COVID guidance here. So this would be when you normally applaud for me. So go ahead and do that while you're sitting back there in your PJs. All right, quick introduction. So, this pandemic has actually kind of shed some light on, on the basically the limitations of our systems and especially older designs and the limitations of those older designs. So I think a lot of folks who have been dealing with issues at hospitals are recognizing that going forward it's more important than ever to make sure these systems are maintained properly and kept up to speed and up to current operational requirements. And it's also taught us that a disciplined and meticulous operational management program with well-defined policies and procedures for these systems is paramount to ensuring these systems remain safe and reliable for patients that may be depending on them for their survival. So the 2021 edition of NFPA 99, not as always, but in this case, for sure, is ahead of its time because we were talking about some of these things before there was a COVID pandemic. So that's kind of interesting that we were able to kind of foresee that we need to continue to kind of update these requirements for operational management. The presentation is based on an article that I wrote that came out, I believe it was in the August issue of Health Facilities Management magazine. So most of the article, if you've already read the article, you might be a little bit bored. There is some new information in here, but like I said, it is based mostly on the information that I wrote in that article. It's always good to kind of refresh ourselves on risk categories or system categories for our medical gas and vacuum systems. This is kind of the major guidance from NFPA 99 on how we apply certain things. And for the most part, we're mostly operating, or most of us are operating in a Category 1 environment where, the failure of our systems may be likely to cause major injury or death to patients. So the expectation is that Category 1 systems are available all the time for life support, and medical gases in an ICU are a good example of Category 1 systems and a Category 1 space, which basically means that we are supplying that space with Category 1 systems. Category 2, likely to cause minor injury to patient, staff, or caregivers, or visitors rather. And these are highly reliable systems with system failure impact limited to minor injury. What's the difference between minor and major injury? Obviously, we're concerned about both. So that's why the differences between Category 2 systems and Category 1 systems are pretty limited. So, and we expect, those systems to be operational most of the time. And those are in areas where procedures can be completed without medical gases. So that's a good way to look at it. And then Category 3 is not likely to cause injury, but may cause some patient discomfort. And currently, we do not have Category 4 medical gas systems. There's been some discussion about using Category 4 for our laboratory gases, but that probably won't get picked up until the next edition of the code, if at all. A little bit on accreditation, Joint Commission, CMS, and I know there's some others, DNV, but basically a lot of them pull from the CMS requirements, and here are some highlights of a few things that kind of have added to, essentially driving hospitals to look for guidance to assist them in developing operation and management programs. And here are some of the requirements that CMS and the Joint Commission have. Basically, the hospital identifies high-risk operating components of the utility system, and then they have an inventory of those. So inventory is a big thing that is required by these accreditation standards, also written policies and procedures, and especially ones responding to utility system disruptions. And when performing repairs or maintenance activities, the hospital has a process to manage risks. And we'll talk a little bit more about that because there's a requirement for permit to work system that we're going to be talking about. And there's some specific maintenance situations that are worth discussing in that. And the hospital tests these systems when they're installed, modified, or repaired, and those results are documented. So we always have to have good documentation of that. And the final one, I continue to, wonder if most people are looking at this and seeing that the Joint Commission does require that we meet all of the NFPA requirements in the 2012 edition of the code. And, one can argue what we're going to talk about next, that is a way to meet the requirements of the code, and I'm one who kind of feels that way, and that's when we're talking about existing systems that are not in compliance with the current code. There's a process that we should be going through to basically risk assess those to make sure that they're not dangerous, essentially. So the NFPA gives us an existing system clause that essentially says an existing system that is not in strict compliance with the provisions of this code shall be permitted to be continued in use unless the authority having jurisdiction has determined that such use constitutes a distinct hazard to life. So it's a high standard. It's basically saying that it's dangerous and, and that an AHJ has determined that. So that statement actually kind of flipped around a little bit in the last code cycle. It used to say that they had to determine that it wasn't dangerous, which is obviously harder for an AHJ to do. So it's a lot easier for an AHJ to say, yep, that's dangerous when they know it's not compliant than for them to say, no, it's not dangerous when they know it's not compliant, because it's kind of a double whammy and puts them in a position where they have to justify it. So, but most of this happens internally to the hospital, where they would find a non-compliant item, probably do a risk assessment to determine if it does pose a risk to patients or personnel or visitors, and then review by the AHJ if they feel necessary for that confirmation. And if non-compliance poses safety concern, then the accrediting bodies have said that you must fix that. So let's correct that, bring it into compliance, and the Joint Commission gives you 60 days to do that for those that are operating under deemed status, which basically means they receive federal funding for Medicare and Medicaid. One of the things about that is the start timer on this time frame is not consistent. So I've heard it kind of starts when you find the non-compliance item, but really you don't know until you do the risk assessment. So I've heard that it starts then, or some other point in time where it makes sense that you've got to fix it. So probably at that point, the 60 days in my mind would start at that point. Let's talk a little bit about risk assessments. Medical gas and vacuum systems are complex and nonlinear. They depend on numerous operating controls, system monitors, environmental factors, and other inputs that can have an effect on the proper operation of these systems. So a systemic approach is necessary when conducting a risk assessment. So the way we're generally doing this is working with the facility to do a compliance review. Probably some of you are doing this during your annual inspections, or maybe the hospital's doing it on their own. And we're going to document those findings, obviously. And then at that point, it's probably a good idea to determine whether those systems are life-supporting or not, or whether they're non-critical systems. And that kind of just allows us to separate sort of the concern over whether there's a compliance issue, as well as identify which systems down the road we may have to be looking at emergency operations planning for. So that does help with that as well. And we may want to look at impacts of unplanned failures of these systems and how we can mitigate them or plan for that, or have an emergency operations plan. The existing system requirements. So in NFPA 99, there's a list of items that no matter what have to meet the code. So there is no applying the existing system clause or doing a risk assessment. And these are the items. They're clearly identified in the beginning of Chapter 5 to let us know which sections apply both to new and existing facilities. So I won't go through all those in great detail, but just know if you're using the 2012 edition of NFPA 99, there is a TIA that changed those requirements. So you want to make sure you reference the TIA and not the original text of NFPA 99 2012 edition. So operation management overview. Since the 2005 edition, the operation and management section of the MedGas chapter has evolved significantly. It does now provide some pretty good guidance to the end users on how to develop an operational management program. And the 2012 edition introduced basically that standard for inspection, testing, and maintenance programs, and specifically calling for inventories, which we kind of talked about a little bit. So critical components, anything that would be on an inspection or maintenance schedule would probably be on that inventory as well. And then another requirement is to have inspection and maintenance schedules, as well as a documented set of standard operating policies and procedures. One of the other major additions in the 2012 was the requirement to have qualified personnel perform these operations. So maintenance, inspections, testing, anything generally around the medical gas systems, now you should be certified or qualified, technically competent to do that work. A little bit more on operational management. The new additions of the code, as well as the significant updates to the Joint Commission and CMS accreditation standards, continue to increase the awareness that the ongoing operational management of these life-supporting systems is critical for patient care. So updating existing policies and procedures will be necessary to meet these new requirements. So I don't know how many of you help your customers with that, but that's definitely something that they're going to be looking to try to address as these new requirements roll out. So, so that might be something that you put in your portfolio to offer. So other aspects of the operational management program, we talked about the inventory and inspection management programs. Obviously, medical gas cylinder management is a big issue for larger facilities and dealing with that cylinder management. Talked about operating procedures, obviously an emergency operations plan for our life support or critical medical gas systems is something that we want to have as part of our program. And then a big one that the Joint Commission is looking at recently in the last couple of years is a new requirement they added, which is system mapping and documentation. So we should have some documentation of our system, critical control valves on a drawing, something that would pass muster as being a map of the system. And then obviously personnel qualification standards continue to increase and evolve. So one of the major things that's come out, and this guy in my normal presentation does a little dance, but technology is such that I'm doing this a little different than I did in the last presentation, so it's not dancing for you. Sorry about that. But basically, the new requirement is to identify a responsible facility authority. So we've talked about this person a little bit, but in the code, I think it was referenced a few times, but we didn't obviously give it a definition or any teeth. But the 2021 edition now has a requirement for a designated responsible facility authority. And that term, again, has been used for a while. Previous editions have stated that reports must be submitted to that person, and that basically it's their responsibility to make sure those systems were adequately tested and that the results demonstrated that the systems are acceptable and safe for patient use. So that again has been in there for quite some time, but now we've given it some life, and the NFPA does go a long way to assist in providing guidance on how to implement this requirement. So the new program is modeled on other codes and standards that are widely accepted throughout the world, namely the British HTM standard, which has been doing this for a very long time, or has had actually a grouping of individuals that are named and authorized to work on systems. So we're kind of moving in that direction a little bit. And then the international ISO standard for medical gas also has something similar to this requirement. The new requirements are meant to be flexible and adaptable to the varying operational structures of different facility management groups that are generally responsible for these systems. One of the primary responsibilities within the RFA program is to implement the code requirements for our medical gas and vacuum systems that are in operation. So who's steering the ship? That would be the responsible facility authority. So obviously it takes a team, but somebody ultimately has to be, providing us with direction and oversight. And so a well-managed system, is essential to patient safety, as we can all agree. An unplanned failure of these systems can have a catastrophic effect on routine patient care. So managing the day-to-day operations are under the duties of the RFA. And since they are varied and diverse in nature, the RFA must be qualified and technically competent to fulfill this role. And we'll talk about that in a second. And if we can agree that maintaining compliance is an art form, then the RFA position does require an artist. So here's some of the acceptable certifications or qualifications outlined in NFPA. And it says that, the governing body shall kind of come up with a job description and prerequisite qualifications. And the code says that they shall be substantially equivalent or superior to any of the various ASSE 6000 certifications. And also, technical competence on that equipment, as well as an understanding of the design of those systems specifically at that healthcare facility. One of the major requirements is code interpretation. So, being able to navigate that regulatory environment is obviously a big, qualification or skill that needs to be present with the person doing this work. It is their primary responsibility. Compliance is the accepted validation that the systems that are being used in hospitals are safe and reliable. That's why we have a code. I mean, that's the whole idea, is that compliance, is a level of operational status that demonstrates that we're basically as safe as we possibly can be, or at least meet those minimum requirements to be as safe as we possibly can be. And then accreditation is confirmation that the organization has organizational and management practices that demonstrate a continuously maintained quality healthcare environment. So, interpreting the code, compliance is an internal function to make sure that we're meeting those standards, and then accreditation is validation that we have practices in place to ensure that we are doing a good job of that. However, code interpretation and compliance are only half the battle for the Responsible Facility Authority. There are some other things that they have to worry about. So we talked about interpreting the code. Conducting risk assessments is a big part of the, of the requirements for the RFA. Developing and enforcing a permit to work system, which we're going to talk about in a little bit. Evaluating and accepting ITM reports and documentation, oversight of critical records, writing and upkeep of medical gas management programs, policies and procedures, and the emergency management program, and then supervising personnel, making sure training and licensing programs are current and up to date, and that our folks that are working on these systems have the proper credentials to do so. So you can see that there's a lot going on there. Obviously, the RFA can't do everything in a large facility, but we do care who the pilot is, right, and who's flying the plane versus all the other people on board that are trying to make your flight or experience such that you're able to, get from A to B, but do it comfortably and make sure that the plane's kept up to date on their maintenance and all that. So that's the idea. We have an RFA that's flying the plane and a group behind them making sure that it all works. Is it practical for the RFA to do everything? Probably not, especially in a large facility. So in small organizations, that might be possible, and overseen by a single individual, especially if they outsource all of their inspections and maintenance and all that, that there's not a large maintenance staff, that might be reasonable. However, in larger organizations, it's likely to require a team of people to ensure that all responsibilities outlined are managed properly. The designated RFA may be shift specific. So we may have somebody designated on the first shift, one on the second, but we may want to have a backup plan, and this is directed more towards hospitals, obviously, than you folks as verifiers or any of the other various areas that you work in. But having a backup for a designated RFA if they're sick or whatever, that makes a lot of sense. It might be useful to define additional roles based on individual expertise and qualifications. Maybe you have a maintenance person who's interpreting maintenance reports or inspection reports because you're not sure about those. That's fine. Obviously, you can designate or delegate these tasks to folks that might be more qualified to do those various functions. The roles should be well defined through policies and procedures, with final accountability resting with that responsible facility authority. A little bit on industry trends. Medical gas systems and equipment are becoming more complicated, both from an operational and management standpoint, all the compliance requirements, accreditation standards we have to meet, as well as from a technological standpoint. Equipment is just getting more and more sophisticated. So, that trend really means that folks that are working on this equipment or managing it have to be, have an understanding of it and be competent, technically competent to sort of maintain or manage those systems. The industry is moving from qualified personnel, which was, feels like it was only introduced not too long ago, but we're moving to more of an authorized personnel program where, it's a subtle point, but it means conceptually that functional responsibilities are assigned to key personnel for accountability, and work tasks become traceable, and they become traceable through the permit to work system, which is what we're going to talk about next. And an example of, why this is important, if we think about it, where does our oxygen come from? It sits out in a liquid form for most folks in a big white tank outside that we don't worry about until there's something wrong with it. But the reality is we can take a look at those molecules and trace them right back to their source. So if there's ever an issue with that, we can figure out where in the process that occurred. So that FDA traceability requirement, is something that we're trying to move into the patient use side as well, where inside the hospital, when work is being performed, we should have a way to go back and review that and make sure that it was done properly. And if not, have some documentation to allow us to correct the problem. So going forward, authorized personnel will have a pivotal role in managing these systems. The management policies and procedures now dovetail with emergency management planning. All right, so the permit to work system, this is going to be a big shock to the industry, especially on the, the facility side or operational management side, because it is a program that's going to take some time to develop. It's almost has to be integrated into the operations. So there's probably some work to do that as well. I don't think, like a lot of things that happen with new code updates, it's not going to be something there you walk into a facility in October and see this in full force. I suspect that there will be some movement on this at a slow pace for some time, and then eventually it'll hopefully make its way into normal operating procedures. So we'll see how that works out, but that would be my guess on how we see this being implemented on the facility side. So the permit to work system, it refers to a management system used to ensure that work is done safely and efficiently, often used in hazardous industries or within hazardous operations. Permit to work system involves procedures to request, review, authorize, document, and most importantly, deconflict tasks to be carried out by frontline workers. So we'll talk a little bit more about those as we go through the requirements. The new NFPA 99 permit system is meant to formalize and codify a policy approach to managing routine work, and that includes maintenance, repairs, and construction activities as they relate to the piped medical gas and vacuum systems. The permit to work system should include developing and enforcing applicable procedures to ensure the uninterrupted continuity and quality of the medical gas systems. So, and these are right out of the code requirements. So the idea is that we are using this model to make sure that our plan to do work on a system ensures uninterrupted continuity and quality of our systems. And if it doesn't, then that's where the work begins, right? So we've got to figure out a way to deal with that known. The permit to work system is not a replacement for a robust risk assessment process, but can help provide context for the risks associated with the work being performed and give us some more information, valuable information when conducting those risk assessments. So I've found this to be very similar to a confined space entry permit system. We have a confined space permit to work system built into our safety plan, and we do have a few locations where there are things in a confined space where we have to go through that permitting process. So in doing my due diligence on how this would normally work, this is the one program that I think is most similar to kind of what the expectation is. And that's because it has multiple layers of review before we start the work. That's one big thing. So, we're talking about it. We're understanding all the risks. We're talking about the scope of work and having a clear definition of that scope of work outlined in our permit, duration and schedule of the work tasks. How long is it going to take? How long do we expect to be shut off or shut down? A chain of command and communication protocols. So how are we communicating what's going on during the work? A method of clear acceptance of the plan. So a sign off by everybody. So we do that on our confined space entry program permit is, we have a permit that literally everybody signs at the end and says, yep, I accept that plan and I'm comfortable performing the work under those conditions. How do we monitor that work during the performance of the work? And then confirmation of the closeout of work. Again, generally a sign off saying, yes, we're complete with our work. Everybody signed off on that. And then a notification to let folks know that our systems are back to, normal operating status. This analogy helps to better understand some of the similar complexities involved in working on critical medical gas systems at a hospital. Some of the policies and procedures that are identified in the new code requirements, again, appropriate communication plan, a chain of command, shutdown and restoration procedures. So we should have documented procedures, standard operating procedures, and most of you probably have that by now. If you're doing backfeeding work, obviously there's some procedures associated with that. Standard operating procedures for the work tasks. So if we're doing construction activities, the installing contractor should have SOPs for their work. Safety protocols, alternative supplies or adjustments to patient care arrangements. Obviously, if we're shutting things down, we've got to make sure we're taking care of patients as well. Competency of those who work on the system, so maybe a validation and that everybody is qualified to be doing the work that they're saying that they're going to be performing. Inspection, testing, maintenance, and commissioning of the systems, and then emergency procedures for interruptions if we have to worry about that. The risks, because of the level of risk in performing some tasks on these systems are far greater than others, it seems counterintuitive to have a one-size-fits-all approach. So one of the things that I've advocated, and this actually comes from the HTM standard, they have what's called a low hazard permit and a high hazard permit. So developing risk-based criteria for these systems is appropriate, and the program may include multiple hazard levels for the permitting process. So this is kind of what I would advocate for. For example, low hazard permit issued for low risk tasks being performed could have less restrictive process to determine staff involvement and approvals, and therefore could generally be issued fairly quickly. So this, and we'll talk a little bit about examples of these in a few minutes. However, a high hazard permit may require more involved review and assessment by multiple departments involving many layers in the planning and execution of the work, with final authorization coming from the executive level of the hospital. So, hey, we need to shut down our oxygen system to replace our bulk gas system. Well, that's going to be a lot of planning, a lot of discussion amongst the facility departments and those that are affected by that shutdown. And that's kind of a good example of a high risk work, which would require a high hazard permit. The risk assessment, while the majority of tasks will be easy to assess whether they are low or high, some tasks will need to be evaluated. So this can be done through a risk assessment. A good example of this, and this is not foreign to us, it's a little bit more foreign to the facilities people, so it needed a little more explanation. But for you, I think you understand this. The example would be isolation of a supply source from the rest of the system for maintenance or repair. So we have a vacuum pump and it's oil lubricated and we need to shut it off and isolate it from the system in order to do, periodic standard maintenance, replace the oil. That may or may not be high hazard work. The code requirement is that when we design our systems, this is important to you, the requirement is that there shall be no single fault failure. So meaning that the expectation during, again, normal operational status is that we have a backup. So a source of supply, if there's a failure of a source of supply, we have a backup for that. And it is automatic and it's in a standby mode. And, in the code, we require a minimum of 2 supply sources for that reason. Well, if we know that we're isolating one of those supply sources during maintenance, does that put us into an area where there's risk? And depending on the situation, the answer could be either or. But we should know that going into the work, and we should be thinking about how we mitigate those risks if for some reason there's a failure of that supply source while we are working on the backup system. Because if the second vacuum pump fails while we are isolated and the drain plug is out and there's no oil in the pump, there's not really much we can do to address that quickly. So that's the kind of thing that we may want to be planning for in our permit to work system. So again, just an example of how we may have to look at things a little bit further than just the task itself. All right, so let's talk about high hazard permits. And again, this is my, these are my kind of add-ons to the permitting process. There's no requirement for a high hazard and low hazard, but this is how I see it. A high hazard permit should be used when the following exists. Anytime there's a chance for the system to be contaminated, or there could be a cross connection. Anytime we're isolating any source of supply that is actively serving patient areas. So shutting off a zone valve in an ICU, where there's a requirement for third-party testing and certification. That one to me is kind of an easy one, because then the expectation is there's some testing that's going to go on. There's some documentation that has to be generated. There's some review of that documentation, and then there is an accepted by the RFA that an accepted report by the RFA that says those systems are ready for patients. Anytime we're using purging or brazing operations, because that would require third-party testing. And then emergency repairs, anytime there's emergency repairs that are required, that might be something we do under a high hazard permit because we're in an emergency situation. And we'll talk a little bit about the emergency status on that in a second on the next slide. But if the high hazard permits will generally require testing by a 6030 certified verifier, then again, that would be kind of where we would want to use a high hazard permit. Prior to the system use, the permit process should include a verification by both the RFA and the verifier that all testing has been completed and system integrity has been achieved or maintained. And this is to confirm that the systems are ready for patient use as required by the code. Now, that is a code requirement. So, it is ultimately up to the RFA to say, yep, we can use those systems for patients. Accepting the verifier's report after review is a method to do that. Okay, so emergencies. So there should be a process to address emergency work. We want to be able to, if we're going to require a permit for that type of work, we want to make sure that we can do that quickly. So immediate approval to proceed with work. There should be a means to expedite that permit process for quick authorization by the RFA or their designee. And I'm throwing that in there because, the RFA might be one person, but maybe not on second shift, but there might be a designated person to sign off on these types of permits in that situation. And that's to ensure that we have, we can perform those emergency operations and complete them in a timely manner. Low hazard permits should be used when for routine tasks, and those tasks would normally not require complicated planning or work hazard analyses. So, some work that I'm sure some projects that you've worked on, you've been required to do work hazard analysis as part of your safety planning. So obviously these are routine tasks, so we wouldn't be doing work hazard analysis on those. The interruption of patient services or use of temporary services for patient care. So if we're not doing an interruption, that could potentially be a low hazard permit. If we don't require a risk assessment, if the use of customized procedures that are not, so we would not be using a low hazard permit when we use customized procedures that are not other than well-established SOPs. And probably low hazard permits do not require a third-party certification. So a good example of this would be a replacement of like-for-like components, like a pressure gauge, maybe in a zone that is non-critical care that you can do after hours, and you can shut the zone off, replace the gauge, and then obviously do some of the functional testing that you would have to do. And obviously you would need to be a qualified individual to do that work and to perform that functional testing. And that's a good example of a low hazard permit. And low hazard permits should not be required for typical maintenance rounds or observations, as they do not affect system operations. So, a lot of hospitals do daily rounds. They check gauge pressures, operational status, to make sure systems, maybe the liquid level of the oxygen in the bulk oxygen tank, those should not be, a permitting type task. Those make, anytime you're not really doing hands-on is kind of the way to look at it. So maintenance rounds, system observations, permits not required. It's just a decision tree that I got from a friend of mine in the UK that outlines kind of a way in which to determine kind of where you need to, what you need to do in terms of permitting, how you classify that work from a permitting perspective. Obviously, you can't really see that very well, so sorry about that. We should have a form for the permit, so this will be an actual permit to work with a place for us to fill out information, sign off. The UK is very specific. They say it has to have like 4 carbon copies, and the yellow goes to a specific person, green to another person. But we're not getting that deep in the weeds. We're just telling you, hey, we've got to have some way to document this. We should be documenting the work to be done, the equipment that's going to be used, and personnel involved in that. And then precautions to be taken when performing the tasks, other work groups to be informed of the work being performed in that area, authorization for that work to commence, duration that the permit is valid, a method for extending that duration if additional time is required, witness mechanism that all work has been completed and the work site restored to a clean, safe condition, and then actions to be taken in an emergency. So if there's a problem, who am I contacting? What am I doing if, am I during that? So kind of a look at a risk assessment of what can happen, and then what are we doing to mitigate that. A little bit on inspection and testing. So the code does continue to look at some of the inspection and testing requirements, and essentially providing a little bit more oversight on construction activities. This is not new, but some of it is being sort of flushed out a little bit more. Inspection and testing shall be performed on all new systems, additions, renovations, temporary installations, or repaired systems to ensure system integrity has been achieved or maintained. So that's the terminology we use in the code all over the place. It basically means, hey, those systems are ready for patient use. That's what system integrity has been achieved or maintained means. They are, able to be used for patients. The definition of breach in NFPA is very broad. It's broad for a reason, because we use that term to make the determination whether we have to do inspection or testing or not. So the code basically says anytime we breach a system, that we have to do testing. And it does deem a system breached at the point of pipeline intrusion by physical separation. So we've cut the copper tubing, or brazing. Obviously, if we're doing that, the system is open to atmosphere as well, or exposed to a nitrogen purge. So we have nitrogen in the system. But it also says that a system is breached when we have a system component removal, replacement, or addition. So, again, replacing a gauge, although that does expose the system to atmosphere, is considered a breach, as well as, maybe removing a filter on a medical air compressor. That is considered a breach. Okay, and again, the reason we have that terminology is that we basically say anytime we breach the system, quote unquote, there will be inspections and testing. Doesn't mean you have to have a verification, and we'll talk about that a little bit. The responsible facility authority shall review these inspection and testing records prior to using the system. Again, that's to make sure that they agree that the system integrity has been achieved or maintained. And then, so what testing is required? Well, breaching involving separation of piping to atmosphere or conducting brazing operations definitely requires a third-party verification. So, and we all know that means that it's an ASSE 6030 verifier. All other breaches may only require functional testing, and that can be done by a qualified individual. So again, I like to use the gauge because it's simple. Gauge replacement because it's simple. So we did breach the system, so we replaced the gauge, probably an ASSE 6040, medical gas maintenance personnel who's perfectly qualified to do that. That repair would make sure the gauge functions properly. So that's a functional test, as well as probably leak check that joint. And to me, that's kind of a functional test to make sure that the component is operating properly and we have not compromised the system. Maybe you want to flush out the system of any ambient air and if there's an oxygen analyzer, check to make sure that our oxygen is back up to greater than 99%. Those are all functional tests documented by a qualified maintenance person and perfectly acceptable in accordance with the code. So a little bit more on the new inspection requirements. Some of these are new. System inspections shall be performed prior to concealing piping, systems and walls, ceilings, traces, trenches, underground, or otherwise hidden from plain view. So this is now the idea that we want to basically do a carcass test inspection or a rough inspection, as we've been doing in the plumbing world for a very long time. Every other utility system in the hospital gets inspected by somebody before we close it up, close up the walls or ceilings to make sure it's installed properly. Generally a pressure test, some sort of test on that system as well. And in our case, NFPA 99 requires that those inspections be done by someone who's technically competent and experienced. And we reference ASSE 6020 inspectors or ASSE 6030 verifiers as being the credentials that we hope to see doing this work. Inspections shall be performed by a party other than the installing contractor. So just like verifications, we don't want to have inspections performed by the same contractor that's doing the installation work. So we may start to see hospitals have 6020 inspectors on site to do this for their facility, obviously verifiers. And there are some states that have already been doing this for a long time. Arizona, California come to mind. I know there's others. So we're just playing catch up here a little bit from the code perspective. And again, in-house personnel can be doing that at a hospital. And part of the requirements for inspections are pressure testing by the installing contractor, as well as labeling of all the piping and valve tagging for all concealed components and piping. So this will be a good chance for us to be able to review those valve tags that are going to be buried at some point in time, look at all the piping above the ceiling and the walls to make sure it's got the proper labeling, and again, doing a rough inspection of these systems. Again, this is one that I see not rolling out super quick, but it is something that we probably want to start to address, in the marketplace and start to flesh out. So with all of that being said, I think we can all agree that medical gas and vacuum systems are an essential utility. So the code continues to view those systems that way, which is why there's a lot of focus on the operational management requirements. I think we've done a good job of keeping everything in one place. So we have both our new construction requirements and on our ongoing operational requirements in the same document. I know some of the other areas of the world, they have those separated. Like the HTM has two standards, one for new and one for existing. But I like to see everything in one because compliance is something we try to do as well on a daily basis. So, so having those in one place, I think is valuable to the end user. Reliable medical gas systems provide critical sources of life-supporting gases that are essential for the proper treatment of patients. So with the addition of the new Responsible Facility Authority requirements, as well as the permit to work system, into those requirements of the code, it is clear the goal is to continue to ensure these systems remain safe and reliable on an ongoing basis, and that responsibility improves reliability. And that's where the title of my article came from. So I think gone on about 50 minutes, so did pretty good on time. I think we're going to probably go live here in a minute or two and take some questions for folks. I may be doing a couple of questions before, if we can get to that. Just some questions that we've received in the past on this, and then maybe, like I said, we'll go to a live audience and we'll take some questions. And I thank you for your time and being here. And I wish we could all be together, and having our cocktail hour and catching up and giving hugs and seeing friends. But I guess we'll just see each other's face on the Zoom screen for now. And look forward to next year seeing you guys. And I'll look forward to taking some questions after this recording wraps up. Thanks again, and we'll see you all soon. All right, so a couple of quick questions. I just went back to the New England Healthcare Engineers presentation that I did a couple weeks ago. And one of the questions that came up was, what's the difference between the verifier and the inspector? And I think our group probably knows this all too well, that essentially the verifier can perform the system verification, as we call it in the code, which is basically all the testing on the systems when we've breached the pipeline or done brazing operations to make sure that the system has been tested, and we're using a whole bunch of equipment to do that, and validating essentially that the system is safe for patient use, similar to commissioning of systems. Whereas the inspector would be somebody who would not be doing necessarily hands-on, but visual inspections, witnessing pressure testing, and again, that's allowed to be performed by the verifier in the new requirements of the code, but we do allow a 60/20 inspector to do that, and that would be similar to a plumbing inspector, local municipal plumbing inspector coming in to do a rough inspection, witnessing pressure testing. One of the things that I did want to talk about real quick on the pressure testing is, for some reason, the code has required that the inspector witness the initial pressure test, which makes sense on the surface because that's done before we close the walls up. But if you'll remember, the initial pressure test is not a time test, but it is a visual test that we essentially increase the pressure to minimum of 150 psi and actually spray leak detectant on every single joint and watch to make sure there's no bubbles. One of the things that I'm going to look to change, because that doesn't make a whole lot of sense from an inspector's perspective, is maybe then having a timed test. And maybe folks want to modify their procedures to kind of incorporate that into their inspections. And maybe, if we have some time during the Q&A, folks that are doing these inspections on a regular basis in some of the states I mentioned in the presentation, maybe they could weigh in on how they do this from their perspective. So that would be one thing to note on that inspection and testing, the new inspection and testing requirements. The second question that I got was whether the RFA, the Responsible Facility Authority, has to have any credentials in any of the current codes. So 2012, 15, or 18, whether there's a requirement for credentialing of that person in previous editions. And the answer is no, we did not address that. It is only addressed in the new 2021 edition. So folks that are operating on earlier editions of the code obviously can ignore that probably for as long as they want to. But folks that are looking towards best practices obviously will want to start looking at this in a little bit more immediate future and try to implement those requirements. Thank you again, and I think we'll probably go live to take some questions from folks that are witnessing this video recording. So again, thanks a bunch, and we'll see you then.